so now it's time to start moving forward in what we would consider our reactions chapter. Okay, of course, there's lots of content that the author places into this chapter, but a lot of this is maybe based on prior knowledge from what you would have learned in physical science. But just like with a lot of other aspects, we like to take some of these applications and maybe dive into it or expand it maybe one or two more steps. And then when you're a senior, you expand that one or two more steps. All right, so what do we mean by that? Well, probably doesn't mean anything to you right now, nor should that. But if we remember that from 2 years ago, was balancing reactions all right?
Yes. Yeah. It was fun.
Okay.
It was a lot of fun.
All right. Well, that's all we can hope then.
I'm excited.
Okay. So with that top one, that might be one of the, I wouldn't say more difficult ones, but you might be having some struggles with that because there are 5 reactions that we talk about, okay? And those went in the order of single replacement, decomposition, single and double replacements. Now we're up to 4, and then of course combustion would have made the 5th one. But one of the things that we want to be able to say in this single replacement reaction, what's really happening there? Is there some oxidation going on? Is there some reduction going on? Well, let's go ahead and explore that. Okay, so without any further context, could anyone complete this single replacement reaction on their own? Let's start with that.
Do you add Li, or is it HLi then plus Cl?
Okay, so you say you're in, some of you might have been saying it correctly, but there's a lot of people saying things at the same time. So we have some lithium chloride, like you said, and then what is left over?
Would that be H2?
Okay? Because we see that gases are diatomic. That's what you see down here, because no one would argue with that oxygen is diatomic since it's also a gas. So what we mean by oxidation and reductions taking place, okay, is the idea of if this is all on its own right now, okay, which it is. So if we look inside the nucleus for lithium, now you don't need to write this part down unless you think, my gosh, maybe when we get towards the end, you say, well, maybe this would help too. But I think this visual aid will help. The atomic number is 3. So what does that mean to you?
It has 3
That'd be like a plus 3?
electrons in it. It has 3
Yeah.
LIs, whatever.
No.
No.
It'd have a plus.
Well, you picked the wrong one.
Protons.
It does have 3 electrons too, but inside the nucleus it's got these 3 protons. And then, of course, we know in the first energy level there's 2. Then in that second one, it can hold 8, but we only put 1. And then there's a reason why there's only 1 there. Where's that placed on the table? It's in the first column. So therefore, all of those would have that in common. Anything from hydrogen all the way down to rubidium. Yes, past rubidium, cesium, and then all the way down to francium. Okay. So 3 protons, 3 electrons. Is there any charge to that?
Plus.
There is? 3 protons and 3 electrons?
Oh, no.
Okay, so what that means is it really doesn't make any sense. You can put plus 0, or maybe it just makes more sense just to put this because it doesn't have a charge. Because those all cancel each other out. Okay? Then what we would have seen happening is, okay, what charge does chlorine have? Okay? What charge does hydrogen have?
+1.
Okay? So then when we go over to that other side, some authors, maybe periodicals, would just put the plus sign there. I just prefer to write it as +1. Same thing with minus. You can just put a dash there, but to me, I just prefer to put -1. But you can do either one. So we have this reactant side set up how it should be. And this is what you would have learned in physical science too, minus, or without these, I should say. Okay? So from our reactant side, what's happening to our product side now? Okay? Did anything happen to the chlorine? Because what does it have for a charge?
Is it +1 or -1?
-1. What about the lithium then?
Is it +1?
Okay, so it changed from this side where it was a 0 to a +1 now. So how is it that we know that? Well, again, if we had 17 protons in here, and we did 2, 2, 6, and then 2, and then 5. All those numbers would give you 17. So the atomic number for chlorine then is, of course, 17. And then what we had over here, okay, this electron is now gone because where did it go on this side? It went to the chlorine here. Because if this electron is here now, how many numbers and letters do we have on the outside? 18. So that must mean there is a net charge of a -1 here. Would we agree with that?
Yeah.
Okay, that's where that -1 comes from. Then over on this side, you had 3 protons in the nucleus and only 2 electrons orbiting around the nucleus. There's a net charge there as well, which means there's +1. That's where, again, those numbers are coming from.
Wait, so how'd the chlorine have a -1 before you did that? That was that minus sign.
Oh, same thing,
Oh, because of the hydrogen.
because of the hydrogen. Yep. So then when we look over here, you have one hydrogen. I guess I didn't need to write it like that. You have one nucleus here with a 1, and then another nucleus here with a 1. And you could say that maybe these are overlapping, whichever. Now, 2 protons, 2 electrons, because that is a very stable bond now. So is there a charge to this hydrogen then? So this is now 0. So we see some things happening that we got some zeros, we got some 1s, and other aspects to this. Because if we get to oxidation reduction reactions, we introduce that here. But then we'll actually hopefully get a little more of an opportunity to explore that a couple chapters away. Okay, so a long time ago, so hopefully we can see that this explains what's actually happening here.
So how'd you get that before you did any of that then? Like, how'd you just know, like right at the start?
With these here,
Yeah. Well, like that the lithium and the chlorine went together. And then there's H2. Like,
well, there's a whole bunch of answers that you could give that maybe none of them right now would be very good. Because in the back part of the chapter, there's an aspect that we call the activity series, okay, which this would explain that. Also, we have hydrochloric acid here that anytime you would add any type of metal to an acid, we know that you're going to give hydrogen gas off. And it's something that is something similar to this, okay? What I mean by that is we'll put the chemical reaction down and it might not mean anything to you, but then when we write the words in there, you can say, oh, I've seen this before. It's like an epiphany where we think, this all makes sense now. Okay? And it's by now where we miss our classmate down, not on the volleyball court right now. That was what, 3 hours ago?
She might have practice.
I thought it was 10 a.m. they had practice.
Oh, maybe. I don't know.
Maybe they have 2 practices.
Maybe.
And maybe they do. So they're having twice the fun then.
Yeah.
Just like this here. You can say hi to your classmate. You might be having twice the fun having practice, but we're having twice the fun doing this. Yeah. Hang on just a moment. Okay, we had to come back because we wanted to make sure we're having twice as much fun here. Now, I don't know if your classmate's going to tune into this. Maybe not. Because unknown to me that the Science Channel has subscribers to it. Does that, okay, so does that mean that, and I didn't know this, once this is done, I can post this to the Science Channel and then you get a notification?
That's if you hit that bell. Yeah, I have my notifications.
That bell icon. That's it.
I didn't post anything yet, so how can there be a bell?
There isn't, because you didn't post
No,
anything.
no, no.
Oh, okay, so now we're going to change subjects now.
No. Like there's a little bell, and it
Like when we subscribe, we can hit a bell and then we'll get a notification.
Oh.
Whatever you post.
So I don't know if
show up on my homepage.
you're okay.
Is this chapter 8?
It is. And I don't know if your classmate has that to this or not. Maybe not. We'll just go with the presumption that she does. See. Oh my, I bet I've missed some good material here.
I bet so too.
See, we can nod our heads yes. I got to tell the freshmen this, and not just the freshmen, other students too, that, okay, we don't have any, we have seniors in here, but none that have taken human anatomy and physiology, okay? Because there's, we call this a cheekbone. It's actually called your zygomatic arch or zygomatic bone, okay? Attaching that is a masseter muscle that will close the jaw. You actually have a buccinator here, okay, that has a couple of functions. And then what that, see, I got to think about this. Seems like there should be one more. But I think your buccinator will also, along with their zygomaticus muscle too, pulls the corners of your mouth up like this. See, you got it. See, and you did not break your face. You cannot break your face by smiling. I got to tell that to students that it's okay. It will not break. Okay? Maybe I had too much fun. Maybe that's my problem. That's why he's so ugly. Yeah, you had too much fun. Or, yeah, he's smiling all the time. And not all the time. Okay. Okay. So what we see happening then is, I think we made reference to this a really long time ago. Okay? O, L, and E. Ole. Okay? And then there's another one. And I wouldn't even know where to tell you to look at this, but this probably at the very beginning of chapter 4, which would have been talking about electrons. Because when we look at these anacronyms, I think we said that, right? Aren't these what we call anacronyms?
Indeed.
The first letter stands for something. Okay? So then, in this case, this means oxidation. The L means loss. Well, what are we losing? Well, electrons. Okay? then when we look at this, yeah, you can say maybe it's short for regulation, but no, we want to say reduction electrons are gained then. Now, whether you look at it in this fashion or not, it's just something that I like to think about in trying to visualize this and say, okay, this is what's happening. Is this oxidation? Is this reduction? It's going to be both at the same time, but how can you tell the difference? Well, you really can't by just looking at this. But let's see once what happens here. Okay. So one of the things that we see, there's one aspect up here that did not change.
The chargers,
There's one of them that has a charge that did not change.
chlorine.
The chlorine, okay? Because that was a -1 on this side, it's a -1 over here, okay? Well, when you're actually just watching the reaction take place and you're just not having any part of it, it's kind of like sitting in the stands, and we would call them spectators. Oh, not get a little ahead of myself here. Spectator ions. Because they're just watching things. They're not doing anything. It was -1 here. It was -1 over here. So that must mean there's only two other choices, the lithium and the hydrogen. One of them gained electrons. One of them lost electrons.
Lithium gained oxygen.
Okay, so how we can make sense of that, okay, this was a zero charge. Now it's +1. So one of them electrons must have done what?
Oxidated? No.
It-
reduction.
It was oxidized
Oxidized.
because
Gained one.
that's a loss of electrons.
That was chlorine. No, that was hydrogen. Right?
Lithium lost.
Yeah.
I thought lithium
This
gained one.
lost but we're looking at the element itself, because didn't we put an X through there? We got rid of one. So if you got rid of it, wouldn't you say you lost that then? Yes. So in that case, lithium then was oxidized. Okay, I'll just put OX. So then what we see happening here
It was
with hydrogen, we're going to take a little detour here. Someone's driving and doesn't know where they're going, so they had to do a little detour there. That's why the line's crooked. Okay. So who's the driver here? Would you admit to that? Oh, you're a good sport then. Okay.
I'm not very good at driving.
me neither.
Kind of bad. I'm not
Okay.
dangerous, but I'm not good at it.
Okay. All right. All right. Okay. So, and I didn't know how long this was going to take. I'm not looking at the rest of these and thinking, oh my God, we're running behind time. I knew this would take a while. But let's see what's going on here. This had a +1 charge. Okay. So then one way you could look at it is what happened to its charge.
It went away.
How did it?
Exactly. It went away.
Got reduced.
So it got reduced.
But it says electrons gained. How is it reduced?
Reduction electron was gained. So
But you can look at it by the charge, and then that was gained over here by each one of them. They each gained an electron. So then this,
so it's backwards. Not backwards, but
yeah, some people might look at it that way. You could say this is backwards, taking a red marker, taking a black marker and writing red. if we really wanted to be specific, please don't.
That's if it's no, but that's okay.
Wouldn't that make more sense?
Yeah,
Yeah.
Yes.
from the lettering.
But then it looks like we're talking about the color red and not actual reduction.
Well, deductive reasoning would say, okay, we're talking about reduction here.
This isn't
Okay.
a color theory?
No. Okay.
I signed up for the wrong class.
So there's different ways that you can, if you want to say, you can look at this, that gained, lost, charges, whichever, okay? So I don't know if looking at the charges makes more sense. For reduction, I think it makes more sense, okay? But maybe for the oxidations, and that's something that you might have to work through. I don't think in 1 year, I don't know, this stuff for you? In a year from now?
Not sure.
Okay, then otherwise the rest we got to. That's why we had to point this out, and then saying maybe for the rest of you, it'll be 2 years from now. Okay, and one of the things that happens when you do get off into college, and say they might expect you to know that, and if you don't, we'll spend a little bit of time on it, but then you're going to get moving again. Okay, so we want to implement some of these terms into some of these simpler reactions. We would not do that for this here, okay, this double replacement. So maybe the best place to stop then would be, let's maybe quickly balance this, okay, and then to do that, what is it that is not balanced? That we have too many on that side, but not enough over here.
Hydrogens.
Okay? So then we got 2 hydrogens there, only 1 here. So we put a 2 there. Now our chlorines are not balanced. We're going to put a 2 here, and then put a 2 in front of here. Okay?
Wait,
You guys don't remember that?
You guys don't remember
this
that?
is like my favorite thing.
Oh,
Okay.
yeah, no, I
Can we
do.
do this
So-
like very slow?
Why'd you, wait.
Sigma.
With what part?
Can you explain that one more time? Just the whole thing, like where you added the.
Okay.
Oh, I see what you did now.
There's 2 hydrogens over here, right? And there's only 1 on this side.
Okay.
So we have to put a coefficient in there it has to be distributed through the entire compound. Okay? So now our hydrogens are balanced, but now our chlorines aren't.
Yeah.
Because now we got 2 chlorines and only 1 over here.
So it makes,
So you put a 2 in front of here to distribute through the entire compound. And then that gives us 2 lithiums though. So then now we got to put a 2 in front of here.
so if you put the 2 in front of the HCl, it makes both the H and Cl have 2?
Yes.
Okay. So you need to fix it on that side.
Yes. That is correct.
2 chlorine.
And sometimes it's just a lot of trial and error.
And that doesn't change like how everything goes together?
No, it just means there's more of them. That's all. Okay. So maybe pick one of these 3. Okay? So then if this is a synthesis reaction, okay, we'll have to do some presumptions here. And we're going to tell you that this has a +3 charge, this manganese. Okay? So when these 2 come together, what's the symbol for manganese? Mn. And then what's the symbol for oxygen? And that would be oxide now. Okay? So
Whoa.
we have Mn plus O2 gives you MnO. Well, we're not quite done yet.
You have to put a 2 in front of the MNO. No, you have to balance it out. Right.
Okay? And maybe does this add up to 0?
No.
It does not.
You have to put a -2 next to the oxygen.
Okay? And then +3 here. That's why we had to put that +3 here.
How did we know it was +3?
Because that's what we're telling you. That's how you knew it was +3. Yes.
Can you use a different color?
Oh, is it not?
Yeah.
Okay. Well, it's probably just fading away a little bit. Okay. So then you got that M, N, O, -2 +3. That does not add up to 0.
So you have to put manganese as 2 manganese, and 3
So your least common multiple is what?
6.
And the answer that you get tells you what to put below. And this is not a value, it's a charge. So 6 divided by 2, 6 divided by 3. Okay?
Magic.
So then we're not balanced. We got 3 on that side, 2 on this side. So therefore, again, your least common multiple, what is between 2 and 3?
6.
Okay? So then let's just try putting a 2 here. Okay? How many oxygens is that now?
4. Oh, frick, never mind.
6. So then we've got 2 here.
You put 3.
Okay? And then how many manganese is this?
4.
Then you only have 1 over here. Okay.
Magic.
So first you need to balance it out with the charges on that side.
Correct.
And then you need to go back and balance it out on the other side of the line.
Correct.
Okay.
Yep. And then we'll maybe explore this a little more like we did up here. Here we don't have any spectator ions because both of them are taking part. Okay? So if you had to guess, okay, what's happening to the manganese
It's dividing by 2.
from this side to this side?
And it's adding electrons. Right?
Did it add or lose?
How did it lose?
Losing.
It lost electrons.
How?
Because this has 3 less electrons over here. That's why there's a net charge of +3.
Oh.
So it got oxidized. So then that must mean that the oxygen then went from 0 to -2. So the number got smaller. It doesn't always have to be positive numbers. They can be negative numbers as well. Because we see this went from a +1 to a 0. That got smaller. This went from 0 to -2. That certainly got smaller. So that's why we see reduction. Okay, that's probably enough for today. We're probably sitting here shaking, thinking, I didn't know chemistry could be this much fun. That's probably not what you're thinking. You could be, but
I'm having a blast.
okay.
Anytime my brain's fried.
All right. Otherwise, it's one of those to where, and I've told my wife this, and we can have it on camera too, because and who knows who could be watching this? Because if you've ever seen, is it Bruce Almighty or Evan Almighty? I can't remember. What's the first one? It's oh shoot, Steve Carell is in it. It was one of his first movies, and then it had yes, what? And then it had I think it's Bruce Almighty as well. Now I can't remember the name of the main character in there all of a sudden. I could think of Steve Carell,
His name's Bruce.
but that's in the movie though. And darn it, this guy was in Dumb and Dumber too. Yes, Jim Carrey. But sometimes I think when you see him he's changing the teleprompter. Has anyone seen the movie? Has anyone seen the movie? Bruce Almighty. Yeah. So then Bruce here sitting at the teleprompter changing that. And then maybe making him talk funny too. And that's probably what I sound like after a while, is Bruce Almighty. Like, see, these are and maybe that's what it sounds like after a while. All right, we'll catch up to you next time.
Please.